Hi, welcome to this lesson on 2D and 3D trig. Let's have a look at question 4. Two buildings, AB which is 35 meters tall and CD which is 22 meters tall, are situated across from each other. The point P lies between these two buildings, so somewhere on the floor here. And then the angle of elevation from P to A, so this angle here, is 55 degrees, and the angle of elevation from P to C, this angle here, is 30 degrees. A tightrope walker needs a cable that connects from line A to line C, so the edges of those two buildings. Determine the minimum length of cable that the tightrope walker will need to connect between the two buildings. Okay. So I see a few triangles in this question, but the one that we should be interested in is triangle APC, because that has the length AC on here. So what is this angle between here? Well, we know angles on a straight line must sum to 180. So that's 55 plus 30, which is 85. So therefore this angle must be 95 degrees. So we have angle APC equals 95 degrees. Reason, angles on a straight line. In this case, straight line BPD. Okay. Do we know the lengths of AP and PC? Because if we do, then we can use the cosine rule to work out the length of AC. Well, I'm given two more triangles that I can look at here. This triangle here, ABP, and this triangle here, CDP. So the length AP that I'm looking for here, I can use one of the trigonometric ratios to solve for AP. So I have an angle, a side opposite the angle, and I'm looking for the hypotenuse, essentially, of this triangle ABP. So in triangle ABP, we have sine of 55 degrees is opposite, which is 35 meters, divided by the hypotenuse, which is AP. So if I cross multiply both sides by AP, and then divide both sides by sine 55 degrees, I have AP as sine, or 35 degrees, 35 meters divided by sine of 55 degrees. Okay, so we've got an expression for AP. And then, in triangle CDP, okay, again, we have an angle. We know a side length opposite that angle. And we want the hypotenuse. So I can say sine of 30 degrees is 22 over CP. And then doing the same algebraic manipulation, we have CP equals 22 over sine 30 degrees. Okay, again, so that'll be important information. So now, we can say that from the cosine rule, AC squared equals AP squared plus CP squared minus 2 times the product of AP times CP times cos of the angle included, which is 95 degrees. Okay, so what I'm going to do is, this AP, I'm going to put it on my calculator and store it in my A value. And then CP, I'm going to put in my calculator, I'm going to store it in my B value. So let's bring up our calculators. So, we said AP is 35 divided by sine of 55 degrees. So that value there, I'm going to take it exactly as it is. I'm going to shift RCL for store, and then right above it, A. Okay. Then for CP, I have 22 divided by sine of 30 degrees, and that exact value, I'm going to go shift store into B. So now essentially this AP becomes just this A squared on my calculator, plus this CP, which is B squared, minus 2 times AB times cos of 95 degrees. So this is on my calculator. Okay, so now I'm going to go A squared plus B squared minus 2 times alpha A alpha B times cos of 95 degrees. And that's going to give me 4,089.31033. Okay, so What I'm going to do is I'm going to leave that value exactly as it is, and therefore to solve for AC, I take the square root of that entire expression. So I'll go square root answer, and that's going to be 63.95. So say approximately 63.95 meters. So if I was a tightrope walker, I would want to be safe and rather have more rope than less rope to walk over. So I'm going to say he'll need at least, so at the very minimum, 64 meters as a good approximation, so that he's got more than enough cable. Determine to the nearest meter how far apart the two buildings are. So their distance is given by this BD. So if we can work out the length of BP and the length of PD and add them, then we've got the length of BD. Okay, so I've got two right angle triangles here. I know an angle, and I want the adjacent side, and I only know an opposite side. So what trig ratio do we know that has an angle, an opposite, and an adjacent side? Tan. So I can say in triangle ABP, tan of 55 degrees is going to be opposite 35 over adjacent BP. So algebraically manipulating that, BP is then 35 over tan 55 degrees. Okay, then in triangle PCD, we have tan of 30 degrees is going to be opposite, which is 22, over adjacent, which is PD. So again, we can write PD as 22 over tan of 30 degrees. Alright, so what I'm going to do is I'm going to store this value, or not store it, I'm just going to actually put it directly onto my calculator and then write the final answer. So it's going to be 35 over tan 55 plus 22 over tan 30. That's going to give me 62.61. So I'm going to say BD, that's going to be equal to BP plus PD, and we did that sum 62.61. But they said to the nearest meter, so I would approximate that upwards to 63 meters. Okay, so to the nearest meter, the buildings are around 63 meters away. And if you think about that, if this is 63 meters, then the cable length, if it's very taut, you know, so it's tight on both ends, and you flatten it out, it should be pretty close to this distance, and we worked that out to be at least 64 meters of cable. So realistically, in a physical world, this would make sense. All right, that's how we would do this type of question. I'll see you in the next one.